All right, we have the situation here, a tomato garden. Produced tomatoes weighing on average 4.32 ounces with a standard deviation of 0.39 ounces. The distribution being normally distributed. Okay, what is the probability that if I sample 100 tomatoes, 10 or less will weigh less than 3. Oh boy, here we go. So pretty wordy, a lot of things going on here. Let me start drawing, getting information here. I got a tomato garden. I'm weighing tomatoes. Great. Weighing tomatoes. The tomatoes weigh, they're normally distributed. The weight of tomatoes are normally distributed. Fantastic. Let me just start creating a little picture. So looks like I had a normal distribution. This is the weight of the tomatoes. I'm going to put weight here. On average, 4.32 ounces. Great. I'm going to just say that is the mean of this distribution, 4.32 ounces. This is my, call this the random variable x, why not? And this is 4.32, fantastic. And a standard deviation of 0.39. Yes, that's not what I wanted to write. Okay. Okay, so here we got, great, we got this information, and what are we doing? What is the probability? Okay, what of what? That if I sample 100 tomatoes, okay, great, 100 tomatoes, this is n is equal to 100. Okay, I'm sampling 100 tomatoes, but what am I doing? 10 or less, 10 or less of the 100 tomatoes. It sounds like I'm counting. Okay, so if I'm counting, I'm going to keep my options open, but I'm going to start thinking, it's this binomial. Okay, what is it I want? 10 or less will weigh, 10 or less of the tomatoes, okay, will weigh less than 3.93 ounces. So I want 10 of these tomatoes to weigh 3.93 ounces or less. Okay. So I'm sampling 100 tomatoes. Great. What I want is 10 or less of them, of these tomatoes, to weigh less than 3.93 ounces. So it looks like success. In other words, what is it that I want to count? What I want to count is tomato weighs less than 3.93 ounces. So this region right here, this is success. So let's see. I'm sampling 100 tomatoes. This is binomial. Definitely n is fixed at 100. The probability of success, is that fixed? Well, I'm sampling randomly, so let's say that is the case. So I'm going to kind of make an assumption about the sampling technique, that it is have independence. Success, failure, yes, this is success is just landing a tomato in this region. Failure is landing a tomato in that region. So it can be broken down. So it looks binomial to me. But if it's binomial, I need to figure out what the probability of success is. And success is landing in this region right here. So success, this must be the probability of success right here. The chance of getting a tomato to weigh less than 3.93 ounces. Okay, so what is this value? So I got 3.93. Let's find the z-score of this thing. This is normal. And divide that by 0.39. And that's going to be my z-score. And that is -1, so the probability of getting a z-score less than -1, if I use again Excel or GeoGebra, is 0.1587, and that one I just have completely memorized. So if you enter equal to norm is dist -1, you'll get that number. That's typing into Excel. If I happen to go to GeoGebra, type -1, I get this 1.1587 as mentioned. If I happen to have a TI-83, believe the command is normal CDF, and this would be -10, -1 would give you that same value. So great. So now I have the probability of success is this. And what is it that I want? I want 10 tomatoes or less. So let's just see if I could do a normal approximation. I got 100 tomatoes times my probability of success, which is 1.587, and this is 15.87, which is greater than 10. And of course, say that's about 16. So 100 times 1 minus 0.1587, it's approximately 84, which is again greater than 10. So if I wanted to do a normal approximation, I can, and I'm going to. So all we're saying is sample size is large enough to use central limit theorem. Fantastic. So you'll notice that I'm going from one type of distribution to a different type of distribution. Well, sorry, a distribution that it's about weights, but this next distribution is not about weights. This is about proportions, sample proportions. So now what I'm saying is a distribution of sample proportions where every single time I'm sampling 100 values. This has a center, which is the probability of success, which is 0.1587. Again, that's my probability of success. And what is it that I'm after? What's the p-hat value I'm after? So I want 10 or less, 10 out of the 100, I want 10 or less. So my p-hat value that I'm after is 10 or less. So 10 out of 100, that's 0.01. So what I'm looking for is 0.1 or less. Okay, so again, all I'm doing is, this is really a binomial question, but I'm going to use the sample proportion to do this calculation instead. So here we go. What am I after? I'm after p-hat being less than or equal to 10%. And to do this calculation, I'm going to change that to a z-score. And let's see what I get. So again, if I rounded 2 decimal places, I'm going to get not that. Again, that's rounding to 2 decimal places. So this is equivalent to -1.61. And again, if I go to Excel, then I can type in norm s dist. If I go to something like a TI-83, 84, I believe now the command is normal CDF, and I would type the following. What is the -10? I keep typing in. The reality is I want -1.61 or less, going out to infinity. But sometimes these calculators do come with an infinity button, and if that was the case, I would type negative infinity. In other words, starting here, go out to negative infinity. But TI-83s, 84s require a bound. So in this case, I'm just putting a crazy z-score like -10, which is way out there, and to a few decimal places, it will give me exactly the same result. Or I can go to GeoGebra and get exactly the same value. So come over here, type in -0.161, hit return, and I see it's 0.0537. If I could just get rid of this now, 0.0537. All right, great. 0.0537, and there we go. The chance of getting a p value less than 10% is 0.0537, or approximately getting 10 or less out of 100 weighing. Let me go back to the original question. What is probably if I sample 100 tomatoes, 10 or less of them will weigh less than 3.93 ounces? The answer to that question is a little more than 5%. That's an approximation.